a really remarkable culture, a global culture. On the one hand, men and women have never been freer to explore all kinds of amazing things. On the other hand, we live in an age where if an ordinary person finds something and the President of the United States doesn't officially sanction it as real, nobody will believe you. That is really unparalleled in human history. Because normally, historically, when scientists have made discoveries, yes, there has been a tussle and there has been tumult and there has been controversy, but by and large, radical paradigm-shifting discoveries have not taken forever and ever and ever to take root in the culture. There has been no ultimate need for official sanction by agencies of government or agencies of academia. It's getting harder and harder for individuals to make meaningful contributions in a society where, as Graham told you this morning, you can find an entire buried city underwater 120 feet from the Indian shore, and unless you're Indian, nobody will acknowledge you found something. Or you could be Paulina Zalitsky, who was the gal that Graham was searching for this morning in his mind. She is the archaeologist who found these extraordinary ruins off the western edge of Cuba, a half a mile down, a city of pyramids and geometry and cut stone. And again, you haven't heard anything about it because there's been no follow-through. It's like there is this huge, invisible, let's coin a cliche, glass ceiling extending over any paradigm that will change human perception of who we are, how old we are, where we've come from, and what we're all doing in this place. And this mission seems to be no different, as you're going to see. Because what's really amazing is, although the spacecraft is not visiting specifically the site of this object, which was found in 1976 on the Viking images of Mars, what it is finding is incredibly relevant to the perennial question that I've been asked now countless times over 20, 30 plus years. Is this a trick of light and shadow, or is it in fact a real statue? And if it is a statue, who is it to? Who made it? And why aren't we allowed to follow the implications of such a stunning discovery just next door? Why do we have to wait for official sanction? This is a dawn shot composited with one of the Mars Surveyor images of recent years. The dawn shot, which is this side, the eastern side, is from the Mars Odyssey spacecraft, named after my departed friend Arthur C. Clarke's infinitely amazing film, 2001. And the left side is a representation from the Surveyor imagery taken when the Surveyor spacecraft first went into orbit around Mars back in 1998. By putting these two together, you can clearly see, and there'll be some other surprises a little later on, you can clearly see that whatever this thing is, it's not a trick of light. For one thing, tricks of light don't have extraordinary crystalline geometry extending for over a mile on the eastern side. This is lit, by the way, not by sunlight, but by pre-dawn light, which on Mars is pretty faint. Look at the incredible reflections and refractions and the color patterns, and you'll see some other stuff shortly that will echo that. Well, this whole place, with this as the centerpiece, is called Cydonia. It is a city on Mars. I can say unequivocally it is an ancient city on Mars. How do we know? Well, one of the ways we know is depicted in this little volume, which is now in its 5th edition, which I started writing in 1987, and I finally decided, with some help from my publishers, that I have to publish some new books because this one is now too big to pick up. I call it sometimes the 25-pound doorstop because we kept adding and adding and adding, and it's now in its 5th edition, and it's sold an awful lot of copies all around the world. It is a testimony to the history of the exploration of the idea that this place is in fact an ancient extraterrestrial, somehow human ancestor city on another planet where it should not be, and that whoever did this left the most impressive scientific credential that one can leave, i.e. a message, a mathematical link, a message that this place knows its own location on the planet Mars geometrically, what they call it geodetically. And for an average clump of rocks, that's kind of impossible. Furthermore, it knows the location of its symbiotic cousin, i.e. the Sphinx and the pyramids at Giza, here on Earth. And the link between these two is that the tan of the latitude, let me go back, okay, one more. The tan latitude of the face on Mars, 40.87 north, equals E divided by pi equals 0.865. And the cosine of the latitude of the Sphinx on Earth, 30 degrees north, is equal to E divided by pi 0.865. And the odds of that happening just by chance are over 7,000 to 1. So as the Russians have termed the face on Mars, the Martian Sphinx, we have mathematical proof that there is some kind of connection between these two amazing complexes on two amazing separate worlds. And all the while this morning when Graham was talking about Egypt, I kept thinking about this link, this astonishing, demonstrable link. Robin and I, in the not too distant future, maybe months, toward maybe the end of the year, are finally going to be able to get to Egypt and to measure the torsion field physics of this complex. And when I say torsion field physics, that definition and all of the interesting things that come with it will be tomorrow morning's discussion at the ungodly Sunday morning hour of 10 a.m. So, since I have to be here, I expect you to be here too. Because among other things, I'm going to explain to you what this thing is doing sitting right in front of the podium. And I wish I brought the instrumentation with me to measure it and all those astonishing crystals in that room over there. Because you're going to see the measurement of this physics is a crystalline measurement of the interaction of matter with the ether, the amplification of certain crystals. And we have a database, a tremendous empirical database now, which we've gathered by traipsing all around the planet, that is pretty extensive and pretty amazing. And we've just gotten back from Hawaii, measuring on the Big Island at the mythical 19.5 degrees, the physics during the partial solar eclipse a week or two ago. And the results are absolutely mind-boggling. Setting us up for what happened some years ago, which is that by looking at the mathematics of the Giza Plateau and Cydonia and the relationships between the structures, we were imbued with a whole new window on this ancient physics, which apparently determines not only the fate of two worlds, Mars and Earth, but the entire solar system as well as the galaxy beyond and a lot of the stuff beyond that, the details of which will follow tomorrow morning. Right now, let me return to Curiosity, because up until the Curiosity mission, we, meaning NASA, had only put these spacecraft on the planet going back about 30 years. Remember, Viking was in 76, and Pathfinder was in 97, and Opportunity and Spirit were in, 2003, 2004, and then Phoenix was somewhat later, 2008, 9, I think. And then finally, we have Mars Science Laboratory, i.e. the Curiosity mission. Now, here's where things get kind of interesting. because this is a partial plot of the many, many proposed sites that NASA scientists had submitted to the agency in terms of a place to land the Curiosity rover. And as you can see, there's a lot of them, and this is after a winnowing process which took out even more. Ultimately, the number of possible places included 4: Gale Crater, Everswald, Holden, and Marworth Vallis up here. And as soon as this list was announced, I kind of had a little pity pat, because guess what? This is not far from this place. And this rover is nuclear powered. Do you know what the projected lifetime, just technical, physical lifetime of this rover is, based on its nuclear power source and the redundancy built in the electronics and the machinery and the drive wheels and all of that? It's on the order of decades. And if I were to tell you the actual number of years, you'd all freak out, so we won't go that route. But it's really, 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 really long. Now, how long could it be? Well, the Voyager spacecraft were launched back in 1977, and they're still out there heading to the stars, and their lifetime is, 77 minus 2013. Figure it out yourself. And they're nuclear powered. Same power source, SNAP nuclear radioisotope thermoelectric generators, where the decaying isotope produces heat, the heat in thermocouples produces electricity, and the electricity runs the instruments and the radios and the telemetry and cameras and all that. So I thought for a moment that we actually had a shot at driving, after the primary mission was over for Curiosity, driving from there to there, which for a nuclear-powered rover with a lifetime of decades is not at all untoward, and that eventually, if we brought enough public pressure, like we did in '98 with Mike Mallon to get the new images from Mars Surveyor of Cydonia, we'd have a chance to actually have our own nuclear-powered rover roving around Cydonia. Well, 'twas not to be. This is what Curiosity actually looks like. It's about the size of a VW. It's a very, very incredibly sophisticated nuclear-powered car with cameras and manipulator arms and wind instruments to measure meteorology and all kinds of chemistry going on inside to analyze rock samples and all that. It is, as we used to say when I was growing up, loaded for bear. I never quite understood where that phrase came from and what it meant. Have you ever tried to load a bear into any place? I mean, some part of that metaphor escaped me. Anyway, unfortunately, here's Cydonia. This is the site they eventually picked, which is about as far away from Cydonia as you could get. Now, did they do that deliberately? No. No, this is not a conspiracy. They did not avoid Cydonia. They just had some places you're going to see that's really, really, really cooler and better in the short term, and has amazing implications for Cydonia in the long term. Now, Gale Crater, which is located over here, not too far from the Spirit rover, in of itself is a pretty amazing place. This is an artist's conception of what Gale looks like as seen from orbit. This is Gale right here. It's a 100-mile wide crater, there's it here, with a mountain in the middle. And the mountain is taller than the crater. And the assumption up until relatively recently was that somehow this place formed due to water, sediments piling up, and then erosion took over and scooped out the sediments around the mountain inside the crater rim, and we're left with this 3.5-mile tall mountain sitting in the middle of a 100-mile wide valley with a rim around it. Recently, NASA has changed this idea. They think now that there was not an epoch when water built this thing, that in fact water did live here. It flowed and pooled in places billions of years ago when Mars was younger and fresher and had all the cool things that the Earth still has. Remember, this is the mainstream NASA view. And that this lump in the middle, the latest information is saying, actually seems to be wind-deposited airborne dust. Now wait a minute. You have wind-deposited airborne dust that forms a 3.5 mile high tall mountain, whichever way you want to say that. This is a profile showing various famous mountains in the solar system. Most of them happen to be here on the Earth at the moment. Here's Mount Everest profile. Here is Mount McKinley. Here is Mount Sharp, which is the name of the mountain inside Gale Crater. It actually has a formal Latin name, Aeolus something or other, and I can't remember it, so I'll stick with Mount Sharp, which is the nickname given by the planetary scientists who kind of decided this was a neat place to go, and it's named after Bob Sharp, who I actually met at JPL many years ago. Bob Sharp was a really cool Caltech geologist known for his innovative thinking. And I always have wondered if they didn't decide to name it Bob Sharp because the peak, as you're going to see, is really, really sharp, like here. Okay? And it's a double, triple pun. Because if you figure out what NASA's really doing at this place, you're really sharp. So, now we have more detailed information from Mars, from this place, from a spacecraft that was launched a couple, 3 years ago called Mars Reconnaissance Orbiter. This is an artist shot of MRO. MRO basically is like flying Hubble over Mars, only looking down instead of up. The resolution is so good it can literally see something on the Martian surface the size of this water bottle from a 180-mile high orbit. And the orbit's not circular, it's actually somewhat elliptical. With that kind of resolution, I had a debate once at the University of Wisconsin with a very religious, devout evangelist, and I bet him that Curiosity would finally be able to tell us if there was intelligent life on Mars, because its resolution was high enough that it could actually count the girders or the rivets if there was such things on the instrumentation and ruins that we see from orbit that are left. Well, not quite, but we're definitely seeing things now that should, in any fair court, allow me to win my bet, which was a dinner somewhere in LA at his expense. Haven't heard from him lately. Must give him a call. See him on Facebook, Twitter. How can any serious person talk about Twitter? And what serious person can say anything in 142 characters? That's why I don't have a Twitter account. Anyway, yes, that takes a while. So this is a little footprint of an MRO frame, because the MRO images are not square, like you take a Brownie picture. They are elongated because the camera is busily scanning sideways as the spacecraft moves over the surface. So you can adjust it to take very long images or drape shorter ones over particular targets that you want to see in high resolution. This is one such image. And as I looked at this, again, here's the tip of Mount Sharp, very sharp. I saw this. This is geometry. The official explanation of this geometric, amazing set of structures is we're looking at waterlogged silicates. Yeah, right. All right, here's another view. If you look really carefully, you'll see this geometric pattern extends into the shadows. The geometry has geometry on it. This looks for all the world like an oblique photograph taken of a suburb, maybe somewhere in Oklahoma after the tornado, with the structures gone and the foundations and the straight roadways still present. Here's another view. How's this for geometry? Now again, the official line is this is just geology eroded by water. And the overall overarching mission of MRO is to go to Mars, follow the water, climb up into this place on those huge bogies, powered by nuclear physics and electric motors that run off the battery charged by the nuclear power source, and to analyze the chemistry of waterlogged silicates. Okay, that's the official mission. In fact, if you look even fairly closely at Mount Sharp, which is this huge pile of stuff in the middle of the crater. This is the crater rim, okay? And this is the apex is way up here. You can't see it, it's off screen. But you can see that there is a geometry to this place that is more and more unusual the more you look. For instance, this is, let me back up a minute. This is an area right down here. And if you look carefully, and we'll enlarge it, look at all of this organized rectilinear geometry. Now, the key thing about looking for artificial structures or the signs of intelligence on another planet is, what is your rule of thumb? How will you know it when you see it? Well, there really is only one, and no less a personage in the planetary science community than Carl Sagan enunciated this rule of thumb for finding ET on other planets decades ago in his first book. He said, and this is kind of burned into my consciousness because it is really true, the first sign of intelligent life on Earth is indicated by the geometric regularity of its design. If you fly over this country, particularly at night, and you look down on cities, they are stunningly geometric rectilinear patterns formed by the streets and the lights. If you look at ruins in the Middle East on aerial photographs, even though they're thousands of years old and sand and dust has drifted over them and time has weathered away the exteriors, you know, the frescoes or the lintels or the appurtenances that decorate architecture, the basic geometry, even under, you know, tens of feet of sand or sediments, still is visible. And you can see that kind of geometry all over here. Or, moving on, let's go to this little rectangle, which is up on the upper slopes, now approaching the summit of Mount Sharp. And if we look carefully here, you can see that there is, again, incipient geometry, which is a line parallel with the upslope direction of the summit, which is somewhere on this scale way over here. So we'll rotate this around because it has been found that the human eye can see geometry better at certain angles than other angles. They found that out by studying geometry in cats, and don't get me started on the experiments, but going closer. Do you see that there is a regular rectilinear pattern on top of the obvious sharp right angles and declivities and the erosion of what used to at some point be artificial designed stuff? Boeing did a study several years ago. I know this because Mike Barra, my co-author on Dark Mission, actually found me a copy. And the reason they did this study is because Boeing was in the business then of building airplanes. Now they build airplanes and spacecraft. And this was in the days before 3D CAT, generated plans and blueprints and that kind of amazing technology. This is when engineers actually had to draw blueprints by hand, and they had to visualize in their mind's eye the final structure as they produced these blueprint plans to then take to be, cut and machined and then assembled. So they had to do all the CAT stuff in their heads. And what Boeing found is that there's about a third of the population that can do this automatically. They can see geometry like this, and they instantly know, artificial, 3D, they can kind of see what it used to look like before it was eroded. There's another third that can be trained to do this. Then there's a third that are hopeless. And into that third, unfortunately, in my life fell Art Bell and George Norrie. No matter what I have shown them, they cannot see geometry. Unfortunately, since they are the individuals who have given this work the largest audience one can imagine, to me that's kind of personally frustrating, because you want to share really cool stuff with your friends, and when your friends consistently don't see what is obvious to you and to a third of the population of the planet, it can get a little frustrating. This now is a larger version or vision of the area where we're going. This is Mount Sharp right there. This is the rim of the crater around it, Gale Crater, 100 and some odd, 100, I forget what the actual number is. It translates to 96 miles, whatever that is in kilometers. I haven't had enough sleep, so I'm not going to do the conversion. It's a pretty big place. And on this place have been supered the landing footprints of the various spacecraft we have sent over the years to Mars, as they've gotten better and better and better about landing closer and closer and closer to really interesting, but at the same time really dangerous places. Like, you would not want to land on Mount Sharp because you would fall off and then the mission would end. So you want to land at the base and climb up toward the top, taking measurements all the way up. This is the Viking footprint from 1976. As you can see, anywhere in this region, if they tried to land Viking here, it could have come down and probably would have died instantly because it would have fallen off a mountain. This is the Pathfinder footprint. Notice how much smaller it is. This is MER, that's the Mars Exploration Rovers, Spirit and Opportunity. This is the Phoenix ellipse. That's the one we sent to the South Pole, South Pole of Mars a couple of years ago. And finally, this is Curiosity's footprint. Look at this tiny size of that target region compared to the huge area covered by Viking. That's a demonstration of how technology has evolved. Primitive rocket-based technology, Newton driving, in the last 40 or so years. So it was not until now that in the public technology sector, i.e. the rocket stuff that we're supposed to believe is all they've got to go out there and look at this material with, we now, with MSL, Mars Science Laboratory, can land, putting that little ellipse, that landing footprint, anywhere around here we wanted. So they put it there. You'll see in a couple of minutes why they put it there. This is the actual arrival. Notice the interesting editorial. You know, they also talked about this as 7 minutes of terror. Talk about programming people. You go to another planet to investigate astonishing wonders, and what do you first greet? 7 minutes of terror. That's a code. That's designed to make you apprehensive of this place. Just one more little thing, you know, you have to watch all these various things. When Graham said this morning he was not a conspiracy theorist, he better join the rest of us soon, because it's obvious that the fix is in, and the only thing that's going to change it is us. Waiting for, I mean, can you imagine finding an ancient city off India and the officials won't explore beyond 15 feet in depth? When the whole thing is just sitting out there, you can see the water and know that if you went out there and down, you'd find amazing, stunning things. Well, there's only one reason that that fix is in. It's because somebody doesn't want us to know who and how old and how amazing we are and have been. And crucially, can be again, which I'll show you at the end of this talk. It's the and can be again that they're really, really, really scared about. So how do you keep people from progressing, evolving, moving forward, moving up to where they should be? You keep suppressing information. You don't let them dig or get access to or find or publish. And then when they do finally get a presentation like the TED Talk, I mean, I am so curious at the fact that he and his colleague were denied not the access to speak to an audience, but they spoke and then they had their stuff removed by some corporate nameless idiot who thinks they can stop progress by simply pulling the plug. What was it Reagan said? I paid for this microphone many years ago. We have all paid for these microphones. We, meaning the American taxpayer, through the NSF, we fund archaeological research. Through NASA, we fund space research. Through NOAA, we fund oceanic research. We should be in charge. And we're not. So, the answer is we got to make more waves. We have to do more of what we've been doing, because if it weren't for the fact that a lot of us have been making noises for many, many decades, I don't think we'd be seeing anything that we're seeing. The new wrinkle, and I've commented on this before, the new wrinkle is that if you put stuff out there, you're going to see some astonishing stuff they've been putting out, but you don't officially comment on what it is, or you don't have the president officially acknowledge what it is, it's invisible. We live in a culture now where everybody's looking for permission to think the unthinkable, and if they don't get that permission, they will not go there. And that wall of secrecy is really the most insidious of all, because it means that you can fragment the culture to where you have a small group of people who know exactly what they're seeing, and you have a huge larger group of people who, because they haven't had permission to think what the small group can independently think for themselves, they are behind the curve. They're not allowed in their own minds, by their own permission slips. They're not allowed to reach the obvious conclusion. And so there is no progress. Well, hopefully after this afternoon we can change some of that. I have a couple of ideas which I will share with you. For all of you who will get up tomorrow morning, I will share. Hey, come on, if I got to do it. So this is how Curiosity arrived on Mars in its 7 minutes of terror. By something called a sky crane, a brilliant technological achievement put together by the geniuses at JPL, the honest guys who really, really, really want to make this stuff work and share as much of it with the American people and the world as they can. And this is a comparison with people of Curiosity and Sojourner, Pathfinder rover, and one of the Spirit rovers. Oh, and these are two guys wearing white coats to make them look like scientists. Look at the size of this thing. This is loaded for bear. And it turns out it is going to a most extraordinary place where the full use of just the 17 cameras this thing carries. 17 cameras. That's not counting all the other cool instrumentation. If it was allowed to photograph and analyze the really cool stuff, and then it was officially announced, you would see a paradigm shift that would literally change the world. But for some reason, that's not being allowed just yet, so I guess we have to push the river. Now, this is a landing footprint of the original Curiosity landing ellipse, with the X marking where they hoped it would come down. And then shortly before it got there, they changed the ellipse to this, moving the center point closer to the mountain. There's Mount Sharp. The whole thing is actually Mount Sharp, but there's the apex up there. And as you can see, if they'd overshot a little more, they would have actually landed in this dark area, which they believe are a series of sand dunes. That would not have been good, because these rovers don't like sand or dust. So you want to land short of there and then carefully work your way through the dunes so you don't get stuck. This is a computer view behind the entry capsule after the fiery entry, with the heat shield blackened on the front. Parachutes haven't popped yet, but look at the shape of this mountain. Geometry, anyone? Oh, and there's Mount Sharp. What if, I started thinking as I looked and looked and looked at all the parameters, what the photography was telling us, what the agency was doing around the edges of this mission, the things they were not saying, the fact that they picked this place of all the places they could have gone, when even to my eye, the imagery coming out from MRO said this place was really, really interesting, and how in the world could they keep secret what was there if in fact our projections were valid? So our mission became to try to ferret out the Curiosity mission. Our first clue that we were really onto something was when they named the landing site after those 7 minutes of terror last August, and they safely put this creature down on this other planet. They named it after my old friend Ray Bradbury. Bradbury Landing. Now, Bradbury Landing has multiple overtones or undertones. For instance, landing, like in Curiosity, lands. Or landing, like in a place where you tie up ships. Ancient ships, perhaps? I mean, Ray wrote the definitive, quintessential ancient Martian civilization tale in the Martian Chronicles. So these are the sand dunes. The landing site, as you're going to see, is right here, and the Mount Sharp is down in this direction. A little closer, you can see we're getting more detail. Now you've got evidence of surface topography in this featureless area, still not on the mountain. This is at the base of the mountain. And finally, here is an MRO image showing various features of the landscape. This is the actual spacecraft. This is where it landed. There is a region here that is much lower in elevation by 20, 30 meters than the landing site. And these are the various pieces of the landing, the back shell and the parachutes and the heat shield, all the stuff that came off during the entry process, leaving MSL, Curiosity, unscathed, sitting very nicely on the surface. This is the actual spacecraft. And these two little light areas in the middle of this weirder colored, lighter area, those are the actual plume impingement points, say that rapidly 5 times, of the landing rockets on the sky crane. They actually disturb the surface, and you can see the disturbances from orbit. This is an MRO color image. Again, able to see something on the order of 5 inches across. Now we're back to our larger context view. We're up here, and the mountain is here, and the idea is to eventually, the idea was to immediately, but then it became eventually, as you're going to see that's an interesting transition, to drive from here down to here, to begin climbing up this mountain and to sample the rocks at various elevations as they were climbing toward the summit. The idea being that if this was based in water, if it was a water-based sedimentary process that formed this mountain, and water being critical, crucial for life, follow the water, then by climbing up this slope, you're basically climbing up through time. You're measuring old stuff here and younger stuff up here. And the gradient in between will tell you, if you analyze the rocks correctly, how the climate of Mars transitioned from the dry, dead, cold place NASA says Mars is now, to the billions of years ago, much warmer, fuzzier, nicer, cooler, greener, more life-embracing place that everyone hoped Mars was a long, long time ago. And the Curiosity mission officially was supposed to document this by traversing from the lowlands to the highlands and measuring all the stuff in between. Let me get some water here because this is kind of dry. We are in a desert. I'm talking about a desert. And the power of suggestion is really, really strong. Why am I thinking of a Western song right now? And the Sons of the Pioneers. And if you remember that illusion, then you're in the right place. Okay, so this is the first photograph that was taken after Curiosity landed, and lo and behold, what do we see on Mount Sharp? We see all kinds of interesting geometry. Now this is interesting because it's not the camera controlled by Mike Malin, who on past record has been known to, shall we say, fudge some NASA imagery from Mars. This is from the independent navigation cameras on the rover, one of those 17 separate sets of cameras, that are controlled by a totally different political group on the rover mission, on the panel of scientists and engineers that actually are running this thing. And it's interesting to me that the first live imagery that came out has really fascinating geometry. Here's a slightly larger view. Again, there are people who will say, it's just geology, it's just strata, calm down, Hoagland, don't, get your knickers in a knot. But if you look at better imagery that came in shortly, you can see this geometry is reinforced and there's a pattern here that is not natural. And finally, if you look at the color imagery, this is a wide angle. Notice, by the way, the color. They started doing something during this mission called white balance adjusted, meaning they showed you images that weren't that horrible, awful blood red that we've seen on all this Mars photography for decades. But they actually showed you a version of the color imagery that looks like it's shot in Arizona, with blue skies, mesas, tan, sediments, rocks. And again, this is all weasel wording, because Mike and I, over the years, on the Enterprise website, have published papers, particularly several years ago. I forget what I called it, but it was something to do with, the color of NASA, showing unequivocally that NASA has been fudging the color pictures from Mars going all the way back to Viking. And there's a very interesting story about the son, the teenage son of one of the project scientists who was on the Viking mission team. And he did something with the color TVs around the lab at JPL, trying to make them look like this when NASA wanted them to look really, really, really red, that almost got him thrown off the lab and forbidden from ever coming back to JPL again. And of course, 30, 40 years ago, we didn't understand what was going on. Now, of course, we do. NASA's mission over the last several decades has been to try to keep Mars as alien and hostile and inhospitable looking as possible. It can never look like Arizona. And yet, on the white balanced imagery, it does. So, again, geometry. Look at the base geometry. So the more this data, and here's a color close-up, showing verticals and layers and geometric patterning. And I mean, this is obviously nothing you could take to the Supreme Court and win, but it is indicative of the kind of mission we could expect if in fact the system was in any way, shape, or form honest. Or there were honest people in the mission who would sneak out and publish and post real data, secure in the knowledge that A, they could get away with it because they weren't officially announcing that it was artificial stuff, it's just pictures from Mars, right? But knowing that folks like us were out here, willing and with the right sized megaphone to comment on the imagery that was going to be coming from Curiosity, which is what this afternoon is all about. This is our first major official comment on what Curiosity has really been finding. This is now a computer projected false color image showing basically heights. The blue purple stuff is the deepest and the gray brown stuff is the highest, Mount Sharp. Again, see how sharp is? And this is from the German, this is from the European Space Agency spacecraft, Mars Express, which has been orbiting Mars since I think 2003, and is run by a different bunch of guys, and they put out some really interesting things that are not part of the official sanctioned take on Cydonia, for instance. Go to the web, Google ESA images of the face on Mars and compare them to the same images taken by Mike Malin, you are in for a very interesting enlightenment, because it was these comparisons that proved to me that Malin has been digitally fudging the images. In other words, he's been using an electronic paintbrush, or we used to call back in the days of analog photography, he's basically, you know, used some darkroom techniques to get rid of the offending artificial looking stuff. Well, the Germans, Dr. Newcomb in particular, who's head of the German imaging team on Mars Express, has given us really interesting data. So when you look at this data and know its source, it's really intriguing that this location right here is where they decided to land, which is among the deepest parts of the crater, aside from the tall mountain sitting in front of them. This is an aerial view now. This is a NASA 3D stereogram showing the various elevations. Here's the landing ellipse for Curiosity. Notice where it lives in relation to Mount Sharp. And for the person who first tells me what this mount really looks like, I'll do something interesting.
It's a face. Go two slides back and look sideways. That, turn sideways, that's the nose.
It's not bad. That's pretty good. All right. I'm more intrigued with the vertical view, as you'll see momentarily. What's interesting is that if you look at the ellipse in this geological construct, this basically is a graphic where the various units of geology of the Gale crater are tabulated here, and you can just read off, you know, low thermal inertia fan, lobate features, mound skirting units, sinuous ridges, high thermal inertia fan, et cetera, et cetera, et cetera. Knock yourself out, okay? This is where they decided to land, which is right where a alluvial fan, boulders brought down slope by water, meets a green unit which is marked high thermal inertia. Now, what is high thermal inertia? Well, when you take an infrared picture from orbit or from an airplane at night and compare it to one taken during the day, surface features that are natural tend to have low thermal inertia, meaning they get hot and cold really, really quickly. Sunsets, they get cold because there's nothing to them. There's sand, dust, and dirt. High thermal inertia means that even in the middle of the night, the units will retain their infrared brilliance, brightness, radiation into space because they have soaked up enough heat during the day and are releasing it slowly enough at night that they stand out against the background. If you were to look with infrared imagery at major cities all over the world, buildings and streets and parking lots and Walmarts have high thermal inertia. So, in looking at this region, I thought, isn't it interesting that they're landing in the one place where these two sets of forces meet? There's the fan, there's the debris downslope from the crater rim, maybe water, you know, ages of rain, billions of years ago, that kind of thing, causing floods. This is the place they landed, and if you read the key over here, the elevation is about as low as you can get in Gale crater. In other words, they're sampling, or they're looking to sample the lowest, 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 bottom, 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 most ancient, ancient, ancient stuff to see what it was made of. This is the image taken moments after Curiosity landed on that stuff. And isn't it interesting that they just happened to have the camera aimed in the right direction to get this stunningly amazing, dramatic shadow shot with Mount Sharp lying in the background? We're told this was accidentally nice. I wonder. This is now the North Rim. The project scientist, during several press conferences, has made curious allusion to these mountains and compared them to the mountains in the Mojave Desert east of Los Angeles. He's been doing this again and again and again. I have a feeling that John Grotzinger is trying to tell us something. I don't have time to go into the decoding of his strange messages, but they're pretty unusual and interesting. In fact, at one point, during one press conference, he actually said that when he joined NASA, which was during the rover Spirit and Opportunity missions, and saw some of its first pictures, his first thought was NASA's faking the data. Now wait a minute. This is an official NASA project scientist publicly saying that NASA would fake data? What's going on here? Is this like, you know, Commander Booker and the Pueblo back in the 1960s and 68 when the North Koreans caught a US spy ship and beat the crew and paraded them out for television and had them all stand up there and basically admit to being spies and scurrilous, you know, capitalist scumbags, et cetera, all the while the crew were blinking with their eyes, Morse code, we are being forced to do this. Is that what Grotzinger is doing on live television during these briefings? Anyway, the more I looked at these mountains, the more this feature caught my attention, because it looks an awful lot like this feature. Except this one is at Dashur in Egypt, and this one is in Gale Crater on Mars. And oh, if we turn on the color, notice again the color of the sky, notice the sharp edges. In other words, the very first big thing that Curiosity saw and NASA officially put out as an official handout was a picture on Mars that appears to be a pyramid. Let me back up. There. Right here. With an attendant side pyramid right next to it. Again, without official comment, every science writer that I know studiously, assiduously ignored the implications of this feature because officialdom hadn't said what it was. We are paralyzed now to where unless it is officially announced, nobody is willing to commit to what is obvious based just on the data, which means we must do something else. So this now is another shot toward the north. Notice this, the height of these rim mountains. All right? We're talking miles here from the crater floor to the top. And then you got this little thing right down here at the base. This is just a random shot taken looking north. What's this? Is that a rock? Is that a set of rocks? Is that an old VW dealership somewhere? Is this why John keeps referring to the Mojave Desert? I mean, the ultimate in insanity is there are actual people on the web claiming that Curiosity is not on Mars, but in fact is in the Mojave Desert taking photographs of a VW dealership out in the Mojave Desert. Now, there are several ways we can prove that this data stream is coming from Mars, not the least of which is if this is made up in Mojave, they know things going all the way back to Cydonia they should not know and are putting in these pictures. And then the question is, why? You know, if you have a cover-up, why would you muck up the cover-up by undoing the cover-up? Say that fast. Moving on. So here we have our rover with shadows sitting out in front of this amazing mountain. This, by the way, is the typical Mars color that they've decided from this mission is what Mars looked like. All right? Really kind of an icky place, wouldn't you say? We got much better imagery. So here's Bradbury Landing, here's our little rover, and the mission design was it would look around and it would basically begin photographing its immediate vicinity. Now, why am I showing you this? Well, remember those two light areas on both sides of the spacecraft? Here's the spacecraft right there, and there's a little light area there and one there. Those are the impingement areas by the descending rocket plumes on the sky crane. Here is what one of those areas looks like close up. And just take a look at something like this or this. In other words, with the scouring effect of the rocket blast blowing away the sand and dust and dirt, it reveals some interesting stuff underneath. Like when I look at this, I don't see a rock. I see incipient geometry indicating that it is some decayed ancient thing that kind of looks rock-like if you don't think there's anything else on Mars, but in fact has very interesting features that are quasi-symmetrical and look like they've been maybe melted or eroded over a long period of time. Here's another view out toward the north in the vicinity of the spacecraft. The scour area is right here at the bottom. Beyond it, we've got something here. What's this? Well, this to me looks like a pump. It's got cylindrical shaft, it's got more shafts coming out, it's got a glint, metallic glint. It's just lying on the surface as if it had been buried formerly, and either the impingement plume of the descending sky crane blew the dust away and revealed it, or it worked its way to the surface the way rocks work their way to the surface in the Mojave Desert because of frost heaves, thaw-freeze cycle, which tends to lift heavy things to the surface. If you do a sketch, which our friend Steve Troy did, here's the photograph. This is Steve's sketch to make certain features clearer. This clearly, to me, is a mechanical object. Rocks do not have flanges, and they don't have gold-plated ends on pipes. Or here's more weird geometry with very sharp edges and symmetry, like broken pieces of something. Here's a slightly better close-up. Here's a sketch showing what's here, and this is Steve's rendition to bring out detail. In other words, you don't see sharp, angular stuff in an eroded environment. It all gets rounded. That's what erosion is. It rounds off edges. It doesn't leave sharp edges unless the intrinsic tensile strength of the object being eroded tends to make it erode along the geometry. Yes? Yeah?
Can you define the scale of size that we're looking at? Like what size is this? Any idea?
Okay, the size of the pump is about the size of this little guy here.
Okay.
All right? And you can work all this out. If you go to the Curiosity website, there are scales. You can actually, you can do a lot of homework. When I publish the paper, which is going to come out of this on Enterprise, I'll put things like scale and all that so that you can relate more easily to what you're seeing. One thing to keep in mind, however, is that scale is not really that important. The geometry is. We tend to think of objects that are familiar as having a certain scale because they're familiar to us. We're 5 feet tall, bilaterally symmetric. We make things that have a certain size. We live in structures that have a certain size, et cetera, et cetera, et cetera. If you had a race of beings on Mars that were either intrinsically much smaller than humans or much larger than humans, their technology would look the same geometrically, but it could be either bigger or smaller. So size is not by itself a very good determination. And that's a really good question about scale, because tomorrow when I talk about the physics, I'll talk about how the physics of different planets directly affects the scale, and how the physics of this planet, up until it sharply changed about 65 million years ago, affected the scale of intelligent creatures or semi-intelligent or on their way to intelligent creatures living here. And you obviously know I'm thinking of dinosaurs compared to elephants and sperm whales. Why don't we have dinosaurs running around anymore? Well, here's a big secret. If Jurassic Park could come true, the T-Rex that they produced would be the size of Marella. Think of it. The size of our dog. A Tyrannosaurus Rex, the size of Marella. Why? Because the physics of the Earth has changed. And the physics I'm going to talk about tomorrow morning is crucial in determining the scale and lifespan of biology. And I've got data. I love having data. Data is my favorite person on Star Trek. No, data is really important if you're trying to argue a very tendacious scientific point. I have data indicating there is an intimate relationship between biology and the physics. And when I show you that connection, I guarantee you are all going to gasp, because it's not intuitive, it's not obvious, it's not something that anybody would readily think of, but it's there in the data. So when you ask about scale, it's an interesting question, but it's not determinative because the physics determines the scale of life forms on various planets, depending upon things like spin, composition, distance from sun. This is not mainstream science now. This is the science we are rediscovering, the ancient lost science of the hyperdimensional torsion field model. So back to the imagery. Here are more bits and pieces. Do these look like rocks? A, in color, or B, in just what they look like? I mean, to me, they look metallic. They look as if they had some kind of alloying, layering, sintering, that you're looking at a fractured piece of something that was part of something bigger and got smashed, and now you're left with a piece. A piece of something you'd find in a desert, near a campsite maybe, on Earth. Then we have this, we're again looking north. Look at that vista. You're now looking probably maybe 300 or 400 feet away. So this thing caught my eye. Remember, this is in the first set of panoramas after Curiosity landed. We get this. Ever seen a rock look like that? Come on. This is what it looks like to me. Anybody know what these things are? I mean, really are, as opposed to what they look like? They're two of the boilers on the Titanic. Photographed by Bob, what's his name, from Woods Hole. Can't remember his name. Anyway, look at the cylindrical shape. This is obviously a cylinder with attachments. Top, bottom, lying canted on its side, on a slight ridge, with geometry on top, looking like these guys. Now, I'm not saying it's a boiler, of course not. Geometry, geometry, geometry. Rocks do not erode looking like that. Or let's take this. This is now right in front of the lander. There's the shadow of the camera. There's the JPL logo on Curiosity. And right almost at its feet, which of course it doesn't have feet, it has wheels, take a look at this. What does this look like? It looks like a Nike on Mars. I'm serious. And it's about the size. This really, when I realized this after I did the measurement back to scale, I got this real weird chill. Did it again. Because it's the size of a child's shoe. An Earth child's size shoe. Notice it's got instep, it's got bright highlights, it's got color, it's got shadow, it's a 3D thingy lying next to other 3D thingies. What if this was an ancient bedroom? Like one of those houses in Oklahoma. Except instead of a tornado, ravaged by time and millions of years of erosion and the overturning of the overburden, so that buried things, buried in floods or avalanches or any one of a number of major planetary catastrophes that we can prove Mars underwent millions of years ago. Suppose after all that time, this object, remember, in an environment where there is no free oxygen, so there's no oxidation, there's no rusting. If this is a shoe, then in that environment, which is kind of like a planet-wide museum, things like this would last millions of years, particularly if they were buried under 10 or 20 or 30 feet of mud and sediment, and then slowly brought to the surface because of the wisp of water that freeze thaws the ground above them. Well, back to our view of the weird cylinder looking like the boiler. Because if you look further out on the landscape, you get this layering. This is an area called Glen Elg, which lies to the east of the original Bradbury landing site. And in contradiction to what NASA had said before the landing, where after landing they were going to drive straight over to the mountain, which remember is down in this direction, they decided to go in the opposite direction and meander their way over several months to this region where three contexts, three areas of geology all meet, and they can sample, again, their mainstream perspective, the geology of Mars at three different layers, all almost in one place. Now, along the way, they took lots and lots and lots of pictures. So I'm going to show you now a random sample of some of the pictures, and I want you to see how much interesting stuff you can spot. Now, you can't see too much in a wide angle. There's not enough resolution. But if you go closer, what the heck is this? Is that a rock? It looks like a double axle cylinder from a 57 Ford pickup. I mean, really? This thing could come run up an 18-wheeler. We should find the rubber somewhere around here, like we saw all that rubber on the road coming over here from Albuquerque last night. The thing you're looking for, forget what it is. You're never going to know till we go there what it is, and even then you probably won't know because geometry rules and the form follows function, but there's so many different forms that you'll never figure out the function. What I will say is you look for symmetry, you look for axial symmetry, radial symmetry, the fact that there's some kind of a pipe sticking out toward the camera. It's canted up on a boulder. It screams symmetry, symmetry, symmetry. Then you look at the color. Color doesn't look like anything around it, does it? Let's back up. Let's look at a wider view. It's pretty unique on this landscape. It looks rusted. Now remember, I said a moment ago that things couldn't rust on Mars. That's not exactly true. There is a wisp of oxygen produced by photolysis. That's the solar ultraviolet light destruction of the carbon dioxide of the atmosphere, splitting the carbon from the oxygen. And there's a wispy trace of oxygen which hangs around for a few hours on the surface. And over time, over thousands, tens of thousands, hundreds of thousands of years, stuff exposed on the surface will rust, but very, 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 very slowly. And what does rust, I mean, I can almost infer from this that this thing has to be made of, iron. Because it looks like rusted iron. So you put all this together, I would bet probably 60-40, maybe 70-30. This is an artificial thing. Don't know what the thing was. May never know what the thing was. But I think it was a thing. Here's another thing. These are called concretions. Isn't that a lovely, neutral NASA agency term? A concretion. Actually, it looks like the eroded top of a fuel tank where you can see the, again, eroded, even width, thickness of the tanking. The inside, of course, is filled with soil and dirt and, you've got shards that are eroding. There's some geometry hiding over here in the shadows, and most of it's still buried underground. Keep in mind this whole plane, we now know uncontrovertibly from the official NASA pronouncement, we're sitting on a floodplain. We found evidence of ancient rivers. Remember they announced that just a few days after landing? We've got evidence of flowing water. And recently they drilled 2 holes, and now we know not only was there flowing water, but all of the prerequisites science has traditionally assigned to the search for life on any other world, starting with Mars, are available at the Curiosity landing site. It is official. Life, no, not big stuff, little tiny guys, microbes, could have existed on Mars. It's official. What they're doing, as I've said on Coast again and again and again, is the Chinese water torture approach to modern science. They drip, drip, drip. In this case, literally, the clues, like lawyers that are lawyered up fantastically in front of a hostile population. They're laying the foundation that now, again, remember in the history books, it will be written on such and such a date in the summer of 2012, well, I guess it was the winter of 2012, which is when they made that first drill. It is now official. Mars could have supported life at this place that was like Earth life, but really teeny tiny. Because remember, microbes don't threaten anybody with ray guns. So they start moving the goalpost edge by inch toward the ultimate conclusion that the big stuff is telling us artificial, tank. Oh, and then there's this little guy. Yeah, that's a rock, right? The color, the geometry, just look at the damn geometry inside. It's something that was eaten away. There's a very famous French artist who produces these works of art. There's one standing in front of the Louvre, I think. There's one at the Vatican. What is his name? But you can Google and you'll see big copies of something like this, except they're not sitting on Mars. They're sitting in very famous places here on Earth. I mean, there even appears to be a shaft running. This thing could have been a motor. It's got enough complexity and symmetry to be a little electric motor. You want scale? This looks about the size of an ordinary motor you could go to Walmart and buy. Except you can't go to this Walmart, not yet. So that brings me to the historical portion and comparative science of our afternoon discussion. Who knows what this thing is? Anybody? Say it again. Antikythera mechanism. Get the gold star. What is the Antikythera mechanism? Well, many, many years ago, decades ago in fact, in the early 1900s, I think it was 1901, there was a scientific expedition to dive on a wreck very close to the island of Antikythera, which is located between Greece and Crete, as you can see from this map. In this dive, the divers brought up a chunk of something. Initially, they didn't even know what it was, but they saved it. It turns out that it is the most astonishing 2,000 plus year old analog computer ever found on planet Earth. And it has taken them decades to figure it out. Notice the gear teeth, geometry. Now the advantage, of course, oh, and notice this thing right here. You see how this is sharp and jagged? That's one way in imagery you can tell the difference between rocks and metallic made stuff. Rocks don't rip. We ought to make it into a bumper sticker. Rocks don't rip. I like that, okay? Here's the backside. Now, obviously, geometry. This is ancient, astonishing geometry, fell in the ocean thousands of years ago. Can you please, I'm kind of, thank you. And it rusted and fossilized. And little organisms built little homes all over it and brought in silicates and padding and layers and little, shopping centers for microbes. This is a bolt, okay? Again, if you, hello? Hello? Yes? Did I say something wrong? If you found this thing, you know, just randomly walking across a parking lot or somebody's, schoolyard, would you ever think that it was interesting, that it had any kind of a history like this? This is an X-ray showing what's inside all that gunk and crud and built up fossilized sedimentary layers. Now, you can't do that to the Mars stuff yet. And they can get close with curiosity. Boy, could they give us some interesting insights to what's really there if they were to reveal what they're seeing. They're not quite seeing this yet. This is the construction, or reconstruction rather, of what this thing was. It was an astronomical computer. An analog astronomical computer, 2,000 years old if it's a day, lying on the bottom of the Aegean Sea, picked up by divers at the early part of the last century, sat on a shelf till a guy named Derek Price, I think that was his name, in the 50s started really looking at this thing. And now we've got all kinds of analyses and 3D, tomography and CAT scans. This is the front, this is the back. This is the comparison to what it looks like now to versus when in plexiglass, the complexity of the gear trains and the layers. And I mean, this is an astonishing object, but it looks like a lump of rock unless you understand what it is really composed of. So, back on Mars. What's this? Think of your precepts. Think geometry, think color as an indication of composition, think symmetry, think curves. Ever seen rocks bend? Ever seen aerodynamic airforms in rocks? I'm not talking about the superficial lamina in deserts where you can have wind streaming that gives you nice erosion curves. I'm talking about, look at the layers in this thing. And then there's more pipes sticking out. And a obviously uniform thick plate at the bottom. And oh, here's some more complex geometry honeycombing over here. I think this is a Martian version of the Antikythera mechanism. Basically, it's a thing that was fossilized after being buried for untold millions of years, has now surfaced through this ground-heaving frost process, and the erosion on the surface is beginning to attack it. But erosion on Mars, because of the extraordinarily thin atmosphere and the lack of oxygen, means that erosion goes really slowly. So this thing could be 65 million years old if it's a day. Moving on. As they continued their traverse toward Glenelg, they took more and more pictures of more and more interesting stuff. Here's another one. There's the base of Mount Sharp in the background. You're looking southeast in this view. And again, if you casually look at this, I wonder if this battery is failing. Can we turn up the gain a little more? Because I don't want to have to eat this ice cream cone. It's not very tasty. Moving over. If you look closely, you begin to see that what look like rocks in the distant view now have an order and a pattern and are sharp-edged, which again, rocks don't erode. Here's another pan showing what again looks to be a traditionally yellowish, greenish Martian NASA landscape. But if you look closely, you'll see different colored stuff, including a rock with an obvious hole in it. Right here. See the reflection? That's the ground behind it. This actually, next to it, has what looks like screw threads. See them? And then you've got this guy over here, nice right angle, looks like angle iron. You've got this thing here, which is really cool. In other words, the more you look at these images, the more they look like thousands of Antikythera mechanisms in various bits and pieces, strewn across the surface, unearthed by that frost heaving process. Here's the enlargement. See the screw threads? See the hole? And the color. They look metallic. Here's another one. Look at this extremely interesting symmetry, and look at this guy over here with all the nicely, evenly shaped geometric holes in it as a thin bent plate. Or this guy up here. What rock looks like it has tank treads on it? Or these guys over here. Look at that beautiful geometry. And on and on. Here's close-ups of some of these guys. They almost look like they are shaped, either shaped blocks or parts of technology. Here's that bent plate with the holes, with the geometric holes, the uniform width plate. And then we move over slightly. Here's our geometry with nice angles, edges, bevels. The more you look, the more debris you see. Okay, here's the wide angle again of the other shot. Notice these guys here. I'm sorry, we'll go to this first. This normally looks like a sedimentary rock, right? Except what sedimentary rocks have flutes on the bottom? Like you were dealing with a metallic plate and it got bent. Rocks don't bend. They break. They shatter. They cleave. You know, think of Leave It to Beaver. Then we've got these guys. If these don't look like two eroded, okay, I'll say it, vehicles of some kind, left there millions of years ago, the scale is about right for a human-sized vehicle. This one almost looks like it has a tank turret top on top. See, it's a cylindrical part. Sunlight's coming in from this direction. You can almost see the symmetry of wheel wells here and here. The problem with reconstructing this stuff is it's so badly eroded that assigning any function to what you see is impossible. The nearest thing we can do is to guess at function, but look at the forms, because the forms give it away. Like in this one. Okay, look at this stuff right here. Look at the beveling, the edges. Look at the geometry of this guy back here. We'll move over. This one, this could be a rock, all right? It's nice and smooth, it's got layering, but I don't know, I just think that's a rock. However, this stuff here and here looks like it's the edges of something that's trying to be exposed, and then we get these guys, all right? There are some people who believe this is the actual exposed vertebra of an ancient living creature. And the reason they think that is because of these spines. I look at this and I see something much more mechanical, almost like this looks like an engine block. Again, I'm not saying that's what it is. It looks like it because it has holes, it's got symmetry. Notice this right angle. Notice the symmetry of the thing on top. Notice it's almost like a little cupola. Again, you need to spend time, and because of Google, you can, looking at these images a long time. And the more you look, the more you will see, the more you will recognize. Now this one is kind of intriguing. Look at that. Okay. All right. Now there are some folks on the web who claim this is a Nazi helmet. Now they probably claim that because of the VW that was found not too far away. Just kidding, just to see if you're all awake. But here we've got another example. Look at this feature here. Look at the shadows. Since when do rocks erode with fingers sticking out like tines of a fork, with sunlight coming down so that we see the shadowing? And then look at the bevels in these so-called rocks up here. This one in particular, look at the symmetry, Look at the up, over. The more you look, the more it looks to me like we're looking at eroded artificial stuff coming back up out of the ground because both of two processes. One is heavy things tend to lift in soils that have any water content, where the free cycle will produce a lifting, expansion, contraction situation. And the other is, we know in the artificial model that a lot of stuff got buried under miles of sediments, and over the last several million years, a lot of that stuff is now dried up and blown away, revealing the stuff underneath, exposed. This made a big splash in the press a few months ago. They called it the chalice, or the chalices, because there appeared to be two silver cups on some kind of a extension, a rod or something, sticking out of this rock. Again, in the model of Antikythera, where instead of finding something in the ocean and bringing it up after it sat on the sediments for thousands of years, we're looking at metallic stuff encased in much softer rock that erosion can wear away, revealing the metallic, because this does look metallic, does it not? This could well be something that should have been investigated, which of course now brings me to the real mystery of the Curiosity mission. What I have shown you in any rational, curious human being should engender such curiosity, I'm on a roll here, so go with me on this, that it would be impossible, if you're a real scientist, not to direct the rover Curiosity to roll over close to one of these things and take lots of close-up images. I mean, we got 17 cameras, right? And do sample analysis. Do you know they've got a ray gun on this thing? They've got a laser that they can point and zap, and there's a hole right in the middle of your forehead. No, they can zap the materials out to 20-some feet and get a spectral analysis so they can instantly tell if they're looking at rock or a refined piece of aluminum or molybdenum or gold or an alloy or whatever. There is not one example, not one, where any of these really remarkable things, some of which bubble to the surface in the global media, social media frenzy now, that NASA has ever followed up on since August. They're following the same pattern they did with Spirit and Opportunity, where we would see really amazing things, and you'd think, oh, any scientists would really, really think that was important to go and look at. And they never go look. This mission, called Curiosity, has the least curiosity of any mission I've ever seen. They don't go look at any of this stuff. I mean, look, it would be so easy if we're nuts to prove that we're nuts. Simply take one of our objects that we've highlighted, go right up to it, subject it to the full spectrum of analysis, and publish almost in real time, within a couple, 3 days, which they can do, the analysis of why we're wrong, why it's not an ancient manufactured artifact. I guarantee you, if you hit the Antikythera mechanism with one of those laser shots, it would tell you it was made of bronze. Bronze does not occur naturally in nature, certainly not as gear trains encased in fossilized concretions. Will they do any of that with all this amazing stuff around this rover? No. They assiduously roll on and on. And now they've stopped at a place and they've drilled 2 holes. Whoop-de-doo. Yes? No. No. Remember, there are no maps of this place. It's all brand new. Every time they send a command to drive this thing 10 feet, 20 feet, 30 feet, they are literally at the edge of the unknown. And with the Spirit and Opportunity rovers, yes, they wandered into sand dunes that they were very unhappy with afterwards. Well, this is a much bigger, more muscular rover with much bigger wheels, and there isn't a lot of sand dunes around. In fact, they had real hard time finding sand dunes, which are the key trap for this rover. We're looking at hard stuff, hard pan, rock, gravel, sedimentary materials, and interesting stuff. And what really bothers me, and it's more and more and more, is that they are not looking close up at any of the interesting stuff, with maybe a coming exception. So I want you all to really pay attention to what's going to happen in the next couple of weeks, because we could be, from my lips to God's ear, we could be on the edge of a paradigm breakthrough. Why? Because of this place. This is a place that they encountered as they rolled down Glen Elg toward a place called Yellowknife and did the drilling there. This is a place they passed several months ago called Shaler. The term Shaler, which of course is an Earth term applied to a piece of Martian geology, turns out to have a very interesting derivation. Go Google Shaler, the scientist, and you'll see why John Grotzinger, I swear, is telling us interesting things between the lines. Anybody here an Emily Dickinson fan? Anybody? Okay, over there. Yeah. Remember her great overall arching mantra? Tell all the truth, but tell it slant. John Grotzinger and the Curiosity team are telling us the truth. They're publishing these images of these astonishing things that are not rocks. They're just telling it slant, because they're not telling us what they are or what they think they are. They're allowing us to democratically do our own analysis. In the Intel community, it's called soak time. If you want to get a population to think in a certain direction, you lay out data, you lay out eventually information, then you let it kind of simmer. You let people play with it, talk about it, write about it on Facebook, or in 142 characters on Twitter. And then you ultimately come out with the official this or the official that. I think we're in that soak time period where they've been laying out all this data, these amazing things, preparatory to maybe finally, after decades, getting pregnant, i.e. announcing their ruins on Mars. This could be one of those things. For instance, in the upper left-hand corner of that other frame, look at this. What does this look like? It looks like a box. It looks like a box with holes in one side. There's the far wall over there. Here's a near wall. Here's another near wall. Okay? Now we move sideways. What is this? It looks like a box with a lid. In fact, it looks like a box with a lid with some kind of writing on it. Again, very, very, very eroded, but look at the edges. Look at the top, look at the bottom, look at this angle, look at that curve coming down, look at that angle, look at that straight line, which is parallel to that straight line. In other words, it's a tilted, canted box. Oh, and scale, it's about the size of a lady's jewelry box.
Ark of the Covenant.
Say again?
The Ark of the Covenant.
Or it's a bit smaller than that. But you're right. We don't know what it is. Remember, that could have been a box. That's what Graham says, what the data is saying about the Ark of the Covenant. The point is that unless there is a process to figure... Now, this is so simple. Let me back up here. All right? Let me show you on the wide angle where this thing is. All right? Come on. That's it. There we are. Okay. The box is right here. Okay? They could drive right up here, park here, be literally 2 feet away, and take super CD color imagery with arrows and circles on the back.
How do you know they haven't?
Exactly. How do we know they haven't? You mean we haven't done that in 50 years? If not, why not? Head should roll. Gross inefficiency. The fact of the matter is, you're absolutely right. They could be doing all of this really cool scientific stuff if they were living up to their damn name, curiosity, and we would never know. Now here is the very interesting news, because it was announced a couple, 3 days ago that on their way to Mount Sharp, hooray, they're going to Mount Sharp, they are going to have to go back by way of Shaler. And they're going to stop and they're going to do an intensive analysis. Now there's a lot of press people who are really intrigued because although they don't see artificial stuff like I do, or if they do, they're keeping really, really, really mum. I can't believe how many dumb science writers there are. I mean, you look at this stuff and it's obvious that it's not a rock. We don't know what it is, but it's not a rock. When did rocks ever have lids? Okay? I mean, look at this. What does this thing look like? Think of color and think of shape. To me, it looks aerodynamic. It actually looks like a hypersonic wave rider, or it could be a kid's toy. An ancient Martian airplane, the toy of an ancient Martian boy who lived on this place over 65 million years ago before it literally went to hell in a handbasket because of the war. Oh, you think I'm being funny? Just wait a couple of minutes, all right? So, other parts of Shaler look like this. And this is not an idle comparison. Look at the horizontal lines, look at the color, look at the vertical lines, then look at this. This looks like a ruin, including this feature here, which almost looks like some kind of eroded metallic clamshell thingy. The objects in front have obvious layers. Some of them have interesting internal geometry with uniform walls. But overall, it's this wavy roof stuff and vertical supports that are regular geometric. We've now moved the camera slightly to the right so you can see the other structure here. They're going to examine this place close up and personal in the next couple of weeks. If they give us honest data, is it possible this is the hinge point on which the future, not only of NASA and the space program, but of the entire human race depends? The first crack in the door that we are alone. Because if they give us real close-ups, I mean, look at how some of this stuff almost looks ragged, like it was some kind of cloth or fabric which was tattered in the wind, particularly over here. See the choppy? But then you've got verticals along with the horizontal choppiness. Again, without better data, we won't know. Okay, this is one of my favorites. Is this a rock? Or is it this? Take a look. Look at the details. Look at the spirals and tubing, and this looks like something smashed together and whipped around and rotated and then buried for several million years and then exhumed like this thing is. Look at the geometry on the front. Look at the ropiness. There isn't, by the way, a volcano to produce rope lava within 1,000 miles. So what did this? This looks like an Antikythera burial. Which then brings us to this. This is a view looking over our shoulder back toward the southeast of the edges of Mount Sharp here. The foreground terrain here, much closer to the camera. This is a few hundred feet away. This is about 8 miles away. All right, so you're looking at several different ridges between you and this. This is the thing I'm intrigued with, right here. All right, here's another view. This is a mesa, maybe. and there's this thing over here. By combining various images that have been released, there's a technique known as additive processing, where you can superimpose various photographs taken at different times. And if you get the geometry right, meaning that you register them perfectly, both in the X-plane and the Y-plane, you can drive down the noise, or in this case, the particular JPEG artifact process that NASA is using to conceal what's there to a certain extent, and you can drive up the signal. So let's take the best imagery we've now been able to assemble and take a look at what this looks like. This is what it is. It is a uniform, highly geometric, apparently glass structure, which has individual geometry inside and is sitting out because it's so close to the horizon, it's foreshortened so that the back part is maybe a mile away, further away than the front part. And as we move along, you'll see it has a uniform width, it's got all kinds of stunning geometry, but the light and the color is interesting because it is too refractive and too bright and too specular to be just geological layering. It doesn't fit the idea of geological layering at all. It looks like the edge of some kind of artificial glass construct with multiple floors. You can actually see at least 3 layers here. And the vertical and the horizontal geometry work together. Here's the wide angle again. Well, you know what it reminded me of? This. This is a frame from the film John Carter. The film that came out just before Curiosity got to Mars. The film that Disney made for a fortune that is really the most amazing depiction of Edgar Rice Burroughs' portrayal of ancient Martians that I have ever seen, done by a brilliant director who did Finding Nemo and the Cars thingy and, you know, the one about the kids' playthings, toys. And he seems to have got the feel for the Martian stuff we're seeing in the Curiosity images pretty down. So what's next for Curiosity? Well, Curiosity is going to be driving from this vantage point toward this mountain over the next several months. By the end of 2013, they are projecting, because the date they're leaving where they are now is uncertain, that they will actually get to the base of the mountain. If they do, and if our model is correct, and if our analysis is accurate, they will be seeing the most stunning things that are unequivocally impossible to hide because the scale will be bigger. They will be seeing geometric things not in the size of boulders, but on the size of houses or malls or shopping centers of intricate unearthed geometry at the edges of this structure. Now remember when I asked you what this thing looked like? This is what it looks like. It's the surviving tip. Good old Mount Sharp, which I believe is actually the top of a huge tetrahedral arcology that was built inside this crater on Mars a long, long time ago. And this is a testable hypothesis. For instance, if you look at this scale, measure the diameter, and begin to look at this geometry and look at this fundamental geometric form, and then you realize that at Cydonia we have that form in triplicate, quadruplicate, the mathematical descriptions of a tetrahedron, which is the cornerstone, the foundation of the physics I'm going to talk about tomorrow morning. Then you look carefully at some of the examples at Cydonia and you find that this tetrahedral form was actually replicated at Cydonia. And if you look at some of the close-ups, you actually can see that the ruins with concavities due to erosion and collapse, because if you have a hollow honeycomb structure, Think a multi-level apartment house, and it erodes from the inside. You'll have collapse of the features in certain directions. If this is what's going on, we can say that a more accurate version of a tetrahedron would be something that looks like this, which is called a Relu tetrahedron, based on something called a Relu triangle. And if you superimpose this geometry over the tholus at Cydonia, it's almost a perfect match. This is the mathematics behind the Relu tetrahedron or equilateral triangle. We see many examples on Mars. Here's one not too far from Cydonia, showing that this feature in the landscape, in fact, is present in many other places on Mars. For instance, here, about halfway around the planet from Gale Crater, is a very remarkable feature which is so sharp-edged that it appears to be almost made yesterday. It is a perfect Relu tetrahedron with a point, the base, the curved walls. It's got obvious erosion, and you can see lots of stuff going on in the vicinity like it's been carved out of the terrain. This is a color version prepared by one of our friends of Enterprise, Keith Laney. You can see the tip, the radial symmetry, the beautiful curves. There's no doubt in my mind that that is what this is. This is a model set up in a garden to show you what this would look like if it was new. Think of each of these divisions as a step, as a floor, as a layer in a structure which for some reason, and that reason has to do with the fundamental mathematics of tetrahedra to the physics of the universe itself, which is where we learned about this in the geometry of Cydonia. This structure is a degraded, eroded version of that model I just showed you. And oh, by the way, over here, there's a nice square doorway. Look at the arrow. Look at the projection. Now, that brings us back to Gale. As I'm looking at the satellite imagery of Gale, here's the apex of Mount Sharp. This is the landing zone where they put Curiosity down. Notice the shape of this thing inside the crater. That bothered me. It was like, it was familiar. One of those things where you look at crop circles and you say, I've seen that, but you don't know where that is. Well, this is what I did. I laid out the geometry of a Relu tetrahedron inside Gale Crater, trying to match visible features and the scale, and this is what I got. Now notice that if I'm right, this was the original form of the original arcology, and look where they landed. Right at the edge. If you wanted to measure the difference between natural stuff and where the arcology began, in other words, you want to look at the lowest base layers, which would be the most exposed, the most accessible to this technology, this is where you would land, which would give you this. Sharpen it up a bit. There we are. Okay. It's perfect. And the prediction of this model is that we should see at the base, where the things are most exposed, the edges of those steps, those levels, those floors. Remember, this thing is 3.5 miles tall. Was that its original scale? Because if you balance a Relu tetrahedron on one face, one side, and put it in Gale at the appropriate scale, this is what it looks like. In fact, it would be a Relu tetrahedron, see the tetrahedron inside? 50 miles tall. Let me repeat that. 50 miles tall. Now, there is no human man-made structure that could stand up, even on Mars, under the 1/3 gravity of Mars, that high. It would collapse of its own weight. So if this is an accurate reconstruction, it has an immediate implication over time because now we're seeing just the remnants after it has collapsed. What we see at 3.5 miles is a pale echo of the original form, again, if this model is accurate. Frank Lloyd Wright, who was probably one of the most renowned architects of our time, proposed out of concrete, steel, and glass to build a mile-high skyscraper in Chicago out of existing materials in the 1930s. And calculating for wind and loading and, you know, things like differential heating from sunlight on one side and not on the other, and even earthquakes, he felt it was practical in the 30s to build a mile-high skyscraper. I don't happen to have it with me, but you know that one of the Middle Eastern countries, those incredibly filthy rich oil baron countries, has built the world's tallest skyscraper, which is I think 1/2 mile or something like that. And they're going to go for a mile. You know it. They're kind of ostentatious. It's an interesting mindset that you would take that wealth and put it into a thing, spearing up into space. Well, that's kind of like the philosophy that I'm seeing behind whoever built the stuff that's in Gale Crater. In other words, what I'm saying is that we're looking on Mars in Gale and a lot of other places I'm going to get to momentarily. Let me see how much time I've got.
As much as you want.
Okay. Jim, that's a dangerous thing to say. Very dangerous. Remember, I'm the anti-Twitter guy. So we look here and we see a technology, a physics, a civilization in this depiction, this sci-fi depiction, that can literally create artificial worlds. There's a name for this type of civilization. And when I look at the solar system, particularly over the last 30 years, that I've been looking at all of the NASA imagery that has been leaked, and a lot of it that's just been put plain on the websites now, and you can just download it. It's like, again, it's disclosure without informing the American people. If you put the data out there and you don't say it's a rabbit, no one will think jackrabbit. It may look like a rabbit, it may jump like a rabbit, it may be soft and fuzzy and furry, but unless someone official says, oh, that's a rabbit, most people won't go there for some reason. They can't make up their own minds. That appears to be the strategy. So I'm looking at the data from the solar system, from NASA, from Neptune all the way into Mercury. And I got to tell you, there is an accumulating database which says that we, in fact, live in a solar system that is the ruined product of an extraordinarily sophisticated, high-tech Type 2 civilization. And that has enormous implications for the future of life here on Earth. Not the least of which is, if these guys could figure out how to make materials strong enough to build a structure 50 miles high, don't you think they could drive the price of gas down to 10 cents again? Or get rid of gas entirely and do something really cool? Now, I'm echoing people like Stephen Greer and Steve Bassett. I mean, all of us together, even though Enterprise doesn't do UFOs, I totally concur with the thematic message of Greer and Bassett and their friends, which is this ET technology, if properly released to the planet, not only will save the lives of 7 billion human beings and make them human, it will save the planet itself. It will totally subvert the reason for war. It will totally subvert the us versus them mentality. It will totally transform all of us into people who stand in awe at our own ancestors and marvel at what they did and what we can do collectively again. And it has to happen. If it doesn't happen, as Bassett said the other night on Coast, the forecast for the future of this planet, as Graham said this morning, we are dysfunctional. We are in a closed system. We are eating our own seed corn. We're devouring our own children. We're starving future generations. We're ignoring education. We're building massive weapons of destruction. And it's all pointless. Because this is a reality which is available to us. I mean, these are primitive ideas for how to mine the moon. What if you could mine an entire star system? There was a brilliant genius named Nikolai Semenovich Kardashev, who was a protege of another brilliant Russian astrophysicist named Shklovsky, who had another protege named Nikolai Kozyrev, who we'll talk about tomorrow morning. I see Robin raising her eyebrows because she knows that name very, very well. Kardashev came up with an idea that Michio Kaku fell in love with so wonderfully that he had to steal it over and over and over again. It was him on Art Bell who talked about type 1, type 2, and type 3 civilizations. What he kind of forgot to tell the audience, although he's been getting better, he's actually doing it more now than he used to, is that his seminal ideas of type 1, type 2, and type 3 civilizations came from this guy. And what did Kardashev propose? In this very innocuous paper in Soviet Astronomy in 1964, at the very bottom of the paper, he talks about some astronomical objects may be artificial radio sources, which was the genesis of the idea that an advanced enough technology could make an imprint on the cosmos to where you could see something and you'd initially think, oh, that's a natural object, but in fact it's an artificial, intelligently designed object emitting a humongous amount of energy, purpose, function, totally unknown, but it is the product of a super civilization in the galaxy or some other galaxy, which are primitive radio astronomy techniques, so Kardashev proposed, could not only see, but could figure out, could decide which was artificial and which was just natural. And so when you begin to expand this idea into space, starting with our own solar system, here's Kardashev's scale. He listed basically 3 civilizations. Type 1, which was able to control the energy of an entire planet. Notice that Earth is only a 0.7. I mean, you really can't control the energy of a planet if you're burning up old dinosaurs. Then you have a type 2 up here, which controls the energy of an entire star. And type 3 was the civilization which could control an entire galaxy. And the separation between each of these was 10 to the 10th. That's 10 billion times more energy per jump in technological level. And his criteria was energy. Something very simple, very direct, very understandable. Ancient Mars, as I have put the pieces together, and there are others that are working on this, and my friend Joseph Farrell and I have had long conversations, and he's written a lot in his books about our projection of Kardashev's scale onto the stuff we're seeing on Mars. The Mars stuff was just a shade below a type 2. Now, a type 2, think about this. If natural materials can't build a structure 50 miles high, but a type 2 has insights into other force fields in nature, like the torsion field I'm going to talk about tomorrow with this wonderful prop sitting right in front of me. Jim, I got to really thank you for that. Okay? That is cool. That is super cool. Then, for that level of civilization, building a 50-mile-high, ego-blaring edifice to the stars fits right in keeping with, guess what? How human beings behave when they have unlimited wealth, unlimited money, and unlimited hubris. And I've been saying for decades that we are the Martians. that the folks living in this room, well, you're not going to be here that long, so don't worry. But the folks sitting in this room, we are heirs to whoever did this. And as such, we can do astonishing things again. I mean, civilizations of the human type that we know of inevitably wind up accumulating energy resources under some leadership that wants to build a lot of stuff, big stuff. Look at the stuff that Ramses left us. Heck, look at the pyramids themselves. Look at Central America. Look at the far Pacific. Where human beings get together, they seem to have a penchant for building stuff. Give them Type 2 civilization technology and they'll build super big stuff. In fact, that's what I think this is. This is now a more refined version of the face on Mars with the Dawn Odyssey shot composited with the Western sunset shot from Surveyor. Look at the geometry, look at the crystalline geometry. As we were driving down here this morning, as we got to Flag, the sun was just coming up in the east. And the moon, the full moon, was just grandly setting in the west. And everything had this silvery, magical quality. And the Sacramento Mountains, the San Francisco Mountains, north of Flag, were glowing. And I said to Robin, do we ditch Jim's conferences, go to the Grand Canyon? Because I took her to Dawn at the Grand Canyon, what, 5 years ago? Something like that?
No, probably 8 years.
8 years. So she could see that when the sun rises over those mesas and buttes in the middle of the canyon, they don't glow. They don't have refractive prismatic colors. They're not made of some iridescent super material that the closest thing I can come to was glass, but boy, this is the kind of glass that would, be probably worth its weight in iridium if you could get a piece of it. No, the civilization that built what we see on Mars was only the beginning. Because we've now looked, and I say we, the Enterprise mission, has now looked at stuff all across this solar system. Like, for instance, these comets that we tend to keep visiting. Weird, strange comets. Here's Hartley 2. Well, guess what, boys and girls? Hartley 2 is one of the close-ups from the spacecraft that NASA sent a couple, 3 years ago to take close-up images. Hartley 2 is not a comet. It's a spaceship. Look at the incredible regular lattice-like geometry. The erosion of micrometeorite sandblasting has removed the hull and allowed us to see inside the intricate, totally coherent, internally consistent structural geometry of a 1.5 mile long spaceship. Now, how did NASA know, just assuming this is the only one that's out there, how did NASA know to send its spacecraft to this one and not just a rock? Is it possible that NASA's working off a secret playbook and they've got lists of objects in space that are remnants of the Type 2 civilization we're proposing, and they've been working down their solar system bucket list, and they're looking at the really, really cool stuff so they can pin down for themselves the extent to what they're going to have to cover up. Let's take Saturn, for instance, one of my favorite places. If you go to Enterprise, you'll find a 5-part series, soon to be, no, maybe it's 6, I forget how many parts. It's been too many years since I started it. I now know enough to finish it. That's the main line here. There's a 5 or 6 part series on the most remarkable moon of Saturn called Iapetus. Iapetus looks like a walnut. Iapetus is 900 miles across, but it's got a ridge running around its equator, which looks like this, or this, which is 60,000 feet high. That's 12 miles. and looks like you had made it out of putting two halves together and butt welding the seam around the middle. Like when we were kids, we used to have these metallic Rapogel globes. Anybody remember the Rapogel globes? And they literally were put together with a seam around the equator. Well, that's what this looks like. And when you look close up on the night side, what we've done here is to superimpose several separate images taken by Saturn light. Have you ever looked at the moon, a crescent moon, on a beautiful clear night, and you can see this crescent, and then in the dark part of the moon, you see the rest of the moon glowing faintly, lit by earth shine, called the new moon in the old moon's arms or something like that? Well, what Voyager did, Cassini, is they swung by Iapetus a couple, 3 years ago in 2004, and they took these night shots where the only illumination was light coming from Saturn. Saturn reflecting light from the sun. And they took several shots. So what we did was we carefully superimposed it in the computer so we drive down the noise and drive up the signal. And lo and behold, if you look carefully, you'll see all kinds of layered decks and rooms and ordered, tattered, battered, smashed geometry on the scale of 900 miles across. I recommend, because it's free, you go to Enterprise and you read the 5-part series, or 6 parts, on Iapetus called Moon with a View, which is an homage to my late friend Arthur Clarke. Because when Arthur wrote the novel, 2001, instead of being constrained by the exigencies of limited special effects, which Stanley Kubrick was back in the 1960s when he made 2001, Arthur put the whole movie at Saturn instead of Jupiter. Because remember, Jupiter didn't have a ring back in those days. And the claim was, oh, we can't build the rings to look realistic. Yeah, balderdash. The movie had to hide the real genesis of the whole 2001 paradigm, which was, in the novel, Arthur finds Iapetus is the most remarkable single object in the solar system. Well, fortunately, before he died, he got to read my homage to him and his prescience that, in fact, he was absolutely right. And someday, when this is all general public and everything's acknowledged, Arthur's genius will stand, as that great line from Forbidden Planet goes, like a beacon in the galaxy. We will see Arthur's name enshrined in a forecast of the most impressive place, which I believe is a remnant, a visible remnant of this incredible high-tech Type 2 civilization of which we are descendants. Think about what that means. Every human being on this planet can genetically trace, if we're right, their ancestry back to these guys who did amazing things. And if they could do it, why can't we? We're only limited by our imagination and the unfortunate ability to kill each other off faster than we educate each other to leave this prison and expand into a true home of human beings, which is the solar system. This is now a close-up from Cassini of the edge of the B ring in the Saturn system. You'll notice this little kind of groove. Looked at more closely, the groove turns out to be a geometric glass-like city in the rings of Saturn. Look at the rectilinear geometry. Look at the shadows on the top of the B ring. Sun is coming in this direction. Look at the linear structures, the vertical structures, the cross-linkage structures. Shadows. This is artificial. This is not clouds of ice or particles and boulders and junk like that. This is basically Larry Niven's ring world wrapped around the B ring. Like this. I've taken away the outer A ring. This is where this structure lives. And before it dies, it is my fervent hope that NASA secretly has a plan to send the Cassini spacecraft down through the Cassini division and take super close-ups of this structure because, oh, did I mention it also lives at 19.5? 1.95 radii out from Saturn is this city in the rings. And 1.95, of course, is a stand-in for 19.5. A number you're going to get very familiar with tomorrow. If you all do what? Get up at 10 o'clock and come and sit here. Now look, this is what the 19.5 means. If you take a tetrahedron, oh, remember that geometric figure? And you encompass it in a sphere, a planet rotating, so it has a north and south pole. The 2 points in the northern hemisphere, 3 points actually, here, here, and here, are at 19.5 north, and the 3 points of the double tetrahedron in the southern hemisphere, because you put 2 of these in this package together, are at 19.5 south. Robin and I just came back from 19.5 north on Earth. Boy, are you going to be surprised at what we found tomorrow morning. So, here's Saturn with the dark side of the rings. And the B ring and the Cassini division is right here. This city, which apparently, because of its position, has been carefully maintained against erosion because of its shielding inside the rings. It's kind of hard to get micrometeorites in there to do a lot of damage, even in the billions of years since this thing was alive and active and inhabited. It is geometrically, again, connected to the bizarre hexagonal form at the north pole of Saturn, which is impelled by the same hyperdimensional torsion field physics we're going to talk about when? Tomorrow morning at 10 o'clock, yes. No, we'll do it at 10. I'm up for it. Anyway, so where would I put the Saturn guys? About the same level as the Mars guys. In other words, they're part of the same contiguous Type 2 civilization, which, if all honesty, seems to have remade the entire solar system in terms of artificial tweaking. Up to and included, but not restricted to, building entire artificial planets. No, not the big ones, smaller ones, for use. And this is what NASA has been exploring for the last 50 years. And not telling us. And it's the not telling us part that really brings up the huge political conundrum as we are coming up to the tipping point of planetary problems on this planet. I've said over and over again that unless we have a game changer, something so big, so radical, so unifying, that everyone on Earth sees themselves as part of something bigger, but in common with what they think of as the other, we are doomed. But I see potential for a game changer on the horizon. And in the next 10 minutes, I'll lay out exactly what it is. This is the moon, the Earth-Moon system. We have this gorgeous silvery object that we looked at all last night as we're driving from Albuquerque to here, glistening, moving with the rotation of the Earth, hanging in the west. At dawn, it was a picture postcard. We had the moon silvery against, backlit from the sun, which is in the opposite direction. Beautiful pink clouds in the east, silvery, purplish mists, and mountain after mountain after mountain under this silvery moon. And I, of all people, am riding along, Robin is driving, I'm sitting there looking out the window, and I'm thinking, there used to be people there. There's stuff there. There's astonishing stuff there. And guess what? It's only 3 days away, even with clunky Newtonian rocket technology. We can go there and bring stuff home, which of course is what Apollo was all about. Apollo, like Curiosity, was a secret mission to go and explore ancient heritage technology, bring it home, and keep it secret from the folks who paid for it. This, for instance, is a crater on the far side of the moon. Look at this incredible geometry in the center. All right? That's not natural lavas and impact melts and, debris. Or look at this amazing geometry on Apollo imagery above a place called Sinus Medi. Look at the wiring. This is incredibly eroded structure from what used to be huge domes arching over major portions of the moon. Like this one. This is a tower. We're seeing it because what we can do now is to take computer technology that didn't exist even in the eye of the most imaginative NASA scientists back in the 1960s. And we can scan and enhance and bring out the details on these Apollo photographs taken by human beings orbiting the moon in the command module, looking out the windows with primitive Hasselblad film cameras. This was taken on Apollo 10. And we can see the dim outlines of a heritage we all deserve to own. In 2009, when NASA sent a spacecraft called LaCrosse to the moon, they swung around the moon initially months before they were going to impact, and they took a series of infrared images. What's interesting is that these images are coded. The cold stuff on the moon is blue. The hottest stuff is red. This is supposed to be right under high noon, so the temperature is about 250 degrees Fahrenheit. This is about 250 below 0 Fahrenheit. So there's a 500-degree spread between not seeing the sun and being under the high noon sun on the lunar surface. The sensitive infrared cameras on LaCrosse dutifully recorded all this. Now let's go closer. Notice what's going on here. This is cold, go warmer, 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 really, really hot. Oh, what's this? Let's go closer. It turns out that upper layer gets cold again before it goes back to the cold of outer space. What is that telling us? There is some kind of layer over the moon, an optically thin layer, dense enough to collect heat from the sun and to glow in the infrared, to give its presence away through infrared radiation, heat radiation, but not to be blatantly visible optically unless you do really clever computer things and bring up the signal in these photographs. In other words, LaCrosse confirmed the existence of a stunning, ancient, high-tech series of domes on the moon that our technology could not reproduce. But guys capable of building a 50-mile-high ReLU tetrahedron on Mars easily could have produced. And again, it's only 3 days away. Back to Mars. If this is true, which it is, and this is true, which it is, and this is true, which it is, then this structure is trying to tell us something profound about the human condition itself. You could almost think of this as a three-dimensional ancient Hallmark card when they cared enough to leave the very best. And the very best in this case is a physics and technology which can liberate the human race and transform us into human beings once again. Through this math and geometry that's laid out all over Cydonia. It's the foundation of the torsion field physics I will describe when? Tomorrow morning at 10, yes, okay. It's the kind of technology which could build worlds like this, which in fact, if you look at the two little moons of Mars, Phobos and Deimos, in our analysis, they did. This again is more regular structural lattice geometry. This thing has been whacked and banged and shattered and split and pummeled by God knows what forces, probably a war, not a good sign, but it's waiting there. And do you know that in terms of rocket equations and the dynamics of Newtonian-driven spaceships and, F equals ma and all that ancient stuff, it's easier with our current technology to get to Phobos and find out what's inside waiting for us than it is to get to the moon. And isn't it interesting? I find it interesting. Some people close to me don't seem to find it that interesting, but I find it interesting that what President Barack Obama did a couple, 3 years ago was to change the priority of all of NASA. He wants to go and visit an asteroid. And in fact, now he has proposed capturing and bringing back and putting into orbit around the moon a small asteroid. Why? I think he knows what's waiting out there, and the paradigm game changer could be when they go out, lasso this thing, bring it back, and discover it's a small Type II civilization spaceship, which we will then have access to 3 days away with current technology, where we could data mine the records, the materials, the science, the engineering, the computers, the libraries. Think of what we could see and what we could learn. This is now a close-up of Phobos. Does that look like rocks to you? I mean, give me a break. Oh, and then if we extend this paradigm to the stars, which is a particular constellation called Aquila the Eagle, of which there is one star called Altair, and a hypothetical planet called Altair 4, visited by a space mission in the 1950s, headed by, now please don't laugh, Leslie Nielsen, in his serious days when he was a damn good actor, before something weird hit him in the head and he decided to, I mean, he was really good. I saw, total non sequitur, I saw a spy thriller set in World War II between England and Germany and all that on a train. And Leslie Nielsen was the chief character. He was brilliant as a deep character actor, balancing relationship and the plot arc and all of this. Anyway, in the days when he was an actor, as opposed to what he eventually went on and did, this film was a seminal moment in his career. And what did he say? What were the lines he was asked to speak in this seminal scene where Dr. Morbius in the Krell lab, the super high-tech Type II civilization lab buried underground in a 20-mile cube? I mean, the codes in Forbidden Planet, I ought to do an evening with Forbidden Planet again, because they're just astonishing what they were trying to communicate, again, in Emily Dickinson fashion. Tell all the truth, but tell it slant in this film. And what he's saying to Morbius when the monster, which is going to come and eat them, which is the kind of objective of the film, to show this real creepy bad guy that is part of Morbius's subconscious, it turns out. What he says to Morbius in this lab is that there's enough energy contained in these dials, 10 times 10 times 10 times 10 to the power of infinity. That is what our Type II ancestors had at their disposal. And something, this is really important now, something went horribly wrong. And what I'm looking at on these images are not, adamantine steel buildings rising miles above the plains of Altair 4. I'm looking at ruins. I'm looking at ruins orbiting the sun. I'm looking at ruins in the form of ancient smashed moons. I'm looking at ruins on Mars, on the moon, in the rings of Saturn. Ruins. Wouldn't it be wise, given that life and civilization is so fragile, that we get NASA, our agency that we're paying to do this, to open up and tell us how they died so we don't follow their example? Was it monsters from the id? Was it something here? Was it what Graham said this morning? There's too much left brain stuff and not enough right brain stuff. We're not loving each other enough. We're hating too many people. I was so pleased 2 days ago to see the President of the United States finally announce this war on terror has to come to an end. We cannot live this way. Hold on. So if, as I believe, Mars was the prototype for Altair 4, the illusions are very thinly veiled as you go through and decode all that script. It's just an astonishing decoding of what the message of Forbidden Planet really was. Forbidden Planet is Forbidden Planet Mars. The telltale message of the Krell, the telltale message of what may have happened in the solar system is the same message, which is human beings, if they lose their humanity, become inhuman and can destroy entire worlds, and did, and must not be allowed to do again. So how do we keep that from happening? Do we keep technologies from all of humanity and condemn them to a terrible, short, and cruel existence? Or do we give them the tools again and give them the wisdom to go with those tools so we supersede what our ancestors obviously failed to do? These are huge questions that every human being on this planet deserves to have a voice in, because they mean nothing less than the fate of the Earth and all of us itself. So this headline, which was on the first online version of USA Today to hit the internet a couple years ago, I'm sorry, about a year ago, "Will we be the first Martians?" is an interesting reiteration of an ancient question that I will pose at the end of this talk, which is almost done. Because in the brief but interesting history of curiosity, there looms something coming up ahead in about a year and a half actually, in October of 2014, that could change everything. There is a comet heading for Mars. It is due to either pass really, really, really close or to hit Mars on October 19th of 2014. Now here's the really interesting surprise. According to JPL's trajectory calculations, they're on the JPL website, if it were to hit, it would hit Mars at 19.5 hours Greenwich Mean Time. And you all obviously get instantly what that means. You are the first people I have discussed this with. I trust you will not be all rushing to Twitter. The implications of this are so profound. What I'm going to do is let you kind of think about this overnight. And tomorrow morning, when? At 10 o'clock, I will tell, as Paul Harvey said, the rest of the story. If this object hits Mars, and it's coming up in a most peculiar trajectory, its closest approach to the sun, and supposedly this huge, millions of years long orbit, is at Mars. I mean, come on, what are the odds? And if it hits Mars, based on the size and projection of the impact energies, as much as 20 billion megatons of energy could be released. Now, the good news is it's not on the Earth. The weird news is it may have remarkable effects on Earth. And good news is those effects could be very positive. For instance, if you look at the over-the-head shot of the angles between the Sun, the Earth, and Mars at the moment of projected impact, that angle is 60 degrees. That angle, of course, is part of the circumscribed tetrahedron. So the question is, what will the effects be on Earth, located several million miles away? Ostensibly, nothing should happen in a Newtonian universe. In a torsion physics universe, one of the things that could happen is that progression of ancient desiccated Mars we've been looking at decade after decade after decade, every 2 years as Mars gets close and then moves away with telescopes, it could wind up this one impact which could create a crater 300 miles across and 20 miles deep. It could release enough volatiles to totally transform the current environment of Mars. It could, in essence, terraform the planet, releasing all that water vapor and oxygen and other materials, kind of like the scene out of, what was the Schwarzenegger film? Total Recall. Buzz Aldrin, a name you probably should know, has just come out with a new book called Mission to Mars, where he talks about how going to and inhabiting and colonizing Mars could wind up transforming the human species on Earth. One can well imagine if this scenario were to take place, you would have spaceships built in orbit, you'd have them assembled, they would travel to Mars, they would do all the things that were projected in the 1950s by people like von Braun for exploring our ancient heritage on the red planet, including the remnants of what we have seen in these images of an extraordinary ancient civilization. I saw this headline on a Life magazine cover in a newsstand walking through Chicago's airport about 20 years ago. And there has been a consistent drumbeat. Every time, every few years, there is a kind of penultimate big picture view of why we should be exploring Mars. And it is because somebody, someday, could live there. Thank you.